Hello everyone. So this is part of my video series on basic statistics, and today we'll be looking at Bayes' theorem. So this example will help us understand how to apply Bayes' theorem or conditional probability. So three boxes contain light bulbs as follows. The bulbs Z, bulbs X, bulbs Y, and bulbs Z have total number of bulbs, out of which some are defective. So a box is chosen at random, after which one bulb is selected randomly from the chosen box. We want to determine the probability that the selected bulb is defective and that the probability that the defective bulb came from box Z. So this question would help us to understand how to define events, how to compute the probability of selecting each box, also compute the probability of selecting a defective bulb from a box, and also apply the law of total probability to obtaining the probability of defectives bulbs, and apply Bayes' theorem to obtain the probability that a defective bulb is from box Z. So this is a common problem we see in statistics. So it is possible that we are selecting one box out of the three boxes, and therefore the probability of selecting a box is 1 out of 3. Then the conditional probabilities of selecting the defective bulb from each box, right? So we have 4 out of the 10 bulb in box S are defective, and 1 out of the 6 bulb in out of the 6 bulbs in Y are defective. So also the probability of defective, which is the total probability law of adding all the defective bulbs from the boxes. So we have 1 over 3 times 2 over 5 plus 1 over 3. That is the proportion that is defective from X, proportion that is defective from Y, proportion that is defective from Z, and we multiply the probability of selecting that box appropriately. So that will give us the probability of defective to be 0.3139. We can therefore apply Bayes' theorem that the probability that a defective bulb is from box Z, that will be the probability of a defective bulb from box Z times the probability of Z over the probability of the total defective bulbs, which is what is going to give us 1 over 3 times 3 over 8 divided by 11 divided by 113 over 360. That will give us 0.398. Among all defective bulbs selected, about 39.8% came from box Z, and we can see that in the table display. Alternative approach to using this is to use tree diagram for solving a Bayesian theorem problem. Is to use a tree diagram, and we multiply across the defective bulbs and to get the intersection of X and defective, Y and defective, Z and defective. By the time we multiply, we'll get all the probability of defective from each box, and then we can add them together to get the total probability of defective bulbs. And then we'll now find the probability that a defective bulb is from box Z. This is an alternative approach using tree diagram, and we'll see that the probability of defective bulbs in the entire boxes is 0.314, which corresponds to the earlier method, and also the probability that a defective bulb is from box Z is 0.398, which is equivalent to what we had earlier. So we multiply the probability along each branch and probability across defective branches. Then we divide the probability of the required box over the total defective bulb. Thank you for listening. We continue the video series. If you find this video helpful, like, share, and I'll be expecting your comments in the comment section. Thank you.